Hi student, welcome to my channel Education Shop. In this video, solve example 11.6 from the book Heat and Mass Transfer by Angel, 6th edition. Cooling of water in an automotive radiator. This is an automotive radiator. From this side, the hot fluid water is flowing in the tube, whose inside temperature is 90 centigrade, and the outside temperature of the hot fluid, that is water, is dropped to 65 centigrade. The air enters to this radiator at a temperature of 20 centigrade. By gaining heat, the air out at a temperature of 40 centigrade. Let's come toward the statement. What it says: a test is conducted to determine the overall heat transfer coefficient in an automotive radiator, that is compact cross flow water to air heat exchanger. Cross flow water means, here if you see that the hot fluid is flowing in this direction and the cool fluid is flowing in this direction, so the flow you observe in this radiator is cross flow. That's why it is called cross flow water to air heat exchangers, with both fluids, air and water, unmixed. As you see in the figure, the radiator has 40 tubes of internal diameters 0.5 cm and length 65 cm in a closely spaced plate finned matrix. Hot water enters the tubes at 90 centigrade at a rate of 0.6 kg per second and leaves at 65 centigrade. This is the hot water that is enters in this tube. Airflow across the radiator to the interfin spaces, and it is heated from 20 centigrade to 40 centigrade. The air enters this radiators at a temperature of 20 centigrade and rises its temperatures to 40 centigrade. Determine the overall heat transfer coefficient UI of the radiator based on the inner surface area of the tube. Well, let me write the data that is given in the statement. The inside diameter of the tube, that is 0.5 centimeter, 0.5 centimeters. In other words, we can write like this: 0.5 multiplied 10 to the power minus 2 meter. The number of tube, that is 40. The length of the tube is 65 centimeter. Here you can see that is 65 multiplied 10 to the power minus 2 meter. Now the T hot temperature in, also you will denote it by small letter T1, that is 90 centigrade, and T hot temperature out, that is 65 centigrade. Also you will denote it by small letter T2, that is 65 centigrade. Mass flow rate of the hot fluid is 0.6 kg per second. The cool temperature in of the fluid, that is air, and you also denoted by the capital letter T1, that is 20 centigrade, and the cool temperature out, that is capital letter T2, it is 40 centigrade. The mass flow rate of the cool fluid is not given. What are our requirements? To find the overall heat transfer coefficient UI. Now come toward its solution. In order to find the overall heat transfer coefficient, we know that the rate of heat transfer is equal to overall heat transfer coefficient, internal surface area, correction factor, and log mean temperature difference, that is, let's say, denoted by delta T LM. We are interested to find the overall heat transfer coefficient. For that purpose, we will first find the internal surface area of the tube, correction factor, log mean temperature difference, and the heat released by the hot fluid. Once we calculate that and then we put in this equation, we can easily calculate the overall heat transfer coefficient. Now let's come first to find the amount of heat released by the hot fluid, that is equal to m dot h Cp. Cp value for water is constant and it is 4.18 kilojoule per kg calorie. Change in temperatures of T hot in minus T hot out. Mass flow rate of the hot fluid is 0.6 multiply 4.18 to T hot in, that is 90 minus 65, multiply, and you will get amount of heat released by the hot fluid, that is 62.93 kilowatt. Next is to find the internal surface area of the tube, that is pi DIL. Pi value is constant, Di is 0.5 multiplied 10 to the power minus 2, L is 65 multiplied 10 to the power minus 2. Simply multiply and you will get the internal surface area, that is 0.408 meter square. Next is to find the log mean temperature difference. For that, first we will find the delta T1, that is equal to T hot in minus T cooled out. Hot temperature in is 90 minus cooled is out is 40, and you will get 50 centigrade. Then delta T2, that is T hot out minus T cooled in, that is 65 minus 20, subtract it and you will get 45 centigrade. Then the log mean temperature difference is delta T Lm, that is equal to delta T1 minus delta T2 divided by Ln delta T1 divided by delta T2. Now put the value just simple, that is 50 minus 45 divided by ln, that is 50 divided by 45. Solve this on calculators and it will give you the log mean temperature difference value, that is 47.5 centigrade. Next we need to find the correction factor from this graph. Here you will see on y-axis the value of the correction factor, and on the x-axis we have the value of the parameter P, and that can be determined by this temperature ratio, and these curved lines represent the parameter R that can be calculated from this formula by putting the values of the inlet and outlet temperature of the hot and cool fluid respectively. In order to find the correction factors from this graph, the important thing is to find first the parameter R and the parameter P. Then we will compare that values, and with the help of that we can find the correction factor. First of all, the parameter R is equal to T1 minus T2 divided by T2 minus T1. Here the T1 value is minus T2 value is 40, and small letter T2 value is 65 minus T1 is 90. Just simply solve this on calculators and you will get the R value, that is 0.8. Now the value of P, that is, you can see from this formula, that is T2 minus T1 divided by T1 minus capital T1 minus small t1. The T2 value is 65 minus 90 divided by 20 minus 90. Just simply solve and you will get the value of P, that is 0.36. With the help of this value of R and P, we can easily determine the correction factor from this graph. If you see here, the value of R is 0.8. The curved line for R whose represents 0.8 is this one, and our P value is 0.36. So here it represents 0.35. The mid of 0.3 and 0.4 represent 0.35. If you follow this line in the graph, here it coincides with the curved line which represent the value of R is 0.8. So if you see here, the correction factor value is here is 0.9, here is 1, there must be 0.95. So it means that our correction factor value will lie between 0.95 and 1, and consider that almost 0.97. I hope you understand how you will find the correction factor value. Here I am writing correction factor value is 0.97. Now we know that Q dot is equal to UI AI correction factor and log mean temperature difference. Let's rearrange this equation for UI, that I can say that Q dot is equal to AIF multiply log mean temperature difference. What is Q dot? That is 62.93 kilowatt. In other words, 2.93 multiplied 10 to the power internal surface area 0.408. log mean temperature difference, the correction factor is 0.97, and the log mean temperature difference is 47.5 centigrade. Simply solve this on calculators and you will get the overall heat transfer coefficient for inside surface. Let me solve this on calculator. Just press this equal button and you will get the overall heat transfer coefficient value, that is 3347.5 watt per meter square dot Kelvin. Let me write this on notebook. I hope you understand. If still there is any confusion, you can ask in the comment section. Please comment if you haven't subscribed. Thank you so much.